I'm the session chair and also the presenters of the session. So I will be presenting the first one, then I will call the next presenters. Okay, so the first one is I'm presenting on behalf of my colleagues. So I will present on IoT-based indoor locating systems, ILS, using Bluetooth Low Energy BLE. So for the introductions, we propose an indoor locating system, ILS, using Bluetooth Low Energy BLE, which can track personal assets in indoor venues to aid a user to trace lost or misplaced items. The system design provides Internet of Things proof of concept for indoor locating-based systems using Bluetooth connectivity topology. And the performance of the system is evaluated in terms of signal speeds, energy consumption, and sufficient distance of deploying both transmitter and receiver. So iBeacon topology from Apple Inc. is selected and acts as a BLE transmitter beacons for this project. The BLE beacons advertise the signal periodically to be received by nearby ESP32 DevKit C modules. Then the received signal strength indicator, RSSI, received by the ESP32 DevKit C modules is then measured and computed to estimate the indoor location positions of the BLE beacons. An MQTT that supports IoT technology is installed on the local computer with WebSocket-enabled features allow the plugin to run on the internet browsers. So Rec application is used to create the user interface, which is in the internet browsers, and it converts the received raw RSSI data into an animated reactive web interface. And using these IoT applications, user can monitor or track the current location of the reported Bluetooth signal devices. And ILS is capable of showing the tracking device using a 2D map on the browser, and it can save consumers' time and make tracking easier. So our objective is here to use the Bluetooth technology for device tracking. So the scope of this project is first is design ILS using BLE, and implementation for indoor locations, design and run the algorithms, integrate ILS in living room for proof of concept, portable BLE devices, analyze the coverage range for effective Bluetooth signals. So the methodology is here. First, in the hardware development stage, we use ESP32 chips for Bluetooth connections. And the system development, we use MQTT. The broker is in the middles, and we use React for the user interface, which includes the securities using TSL. And then the output will be on the browsers. So first, the experimental. Two experiments scenarios using WGX beacons was conducted. The first one is a 1.5 meters times 50 meters indoor corridor for RSSI analysis. And the second one is the 5 meters times 10 meters indoor living room to determine system accuracy. So both scenarios 1 and 2, radio frequency devices and house furniture were present. The indoor environment was considered noise containing signal reflections and obstacles in terms of the line of sight, which creates a real living scenario of an indoor building suitable with ILS deployment. So here we have the beacon case, then the WGX beacon with the Bluetooth chips, and then the CR24050 lithium batteries to produce energy to this beacon. So first, the scenario number 1, we have a 1A and 1B. And in scenarios 1A, RSSI readings were collected at each distance, which is 2 meters, 4 meters, 6 meters, 8 meters, 10 meters, 12 meters, and 50 meters. And in scenarios 1B, 10 RSSI readings were collected while moving toward and backward at each distance to another distance of 1 meter to 5 meters. So 4 sets of RSSI samplings were collected in scenario 1B to compare the results. And the RSSI samplings were collected using a BLE-supported Android phones and installed a BLE scanner 4.0 and Light Blue Explorer applications. So we will compare these two BLE scanner 4.0 and Light Blue Explorer applications. So first is the analysis result for the BLE scanner 4.0. And we obtained that when the distance increased, the decrease of average of RSSI, we have the minimum errors of each distance here. and it is quite a very low errors for each distance, and the distance from 2 meters to 50 meters were measured.